Hey guys, welcome back to AlgoYogi. We are doing linked list series right now. We have already started it. 2 problems already done. Next problem is linked list cycle. Let's visit the problem on LeetCode. Given head, sounds really weird, but given head, the head of a linked list determine if the linked list has a cycle in it. And there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. And internally, pos is used to denote the index of the node that its next pointer is connected to. Note that pos is not passed as a parameter. This is just bullshit. I don't know what the fuck they said, but doesn't really matter. I don't know. Return true if there is a cycle in the linked list. Otherwise, return false. So basically, as you can see in first example, there is a cycle because 4 is pointing back to basically next pointer is pointing back to 2, and then it's going to keep looping in here. That means you can't really have a tail for this. Second example also is basically having a cycle, and that's because 2 is the tail, was supposed to be tail, but it's not tail anymore. It's pointing back to 1. It's basically like full cycle. And then 1, it's not true for this, but that's because it's just one node. So anyway, how are we going to do it? So there are actually 2 ways. Let me switch the view. First is having using like some memory structure so that we could store our values into, maybe let's say we can say set. So we could store all the nodes into a set, and then while we are visiting, then we could check if that node has already been visited. If that's already been visited and we are again seeing it, coming back to that same node again, because some pointer, if it were to have a cycle, must have pointed back to that particular node, and we have already stored it in our set. We find it out, then it's basically it has a cycle, then we return true, otherwise we return false. But this is basically big of n time complexity solution, but also it takes big of n time, not n time, and space complexity. And this problem has basically asked us that can you solve it using big of 1? So let's just solve it using big of 1, and I think the first solution is easy and you guys can do it. Now let's move on to the second solution, which is basically the optimized solution using constant amount of memory and big of n time complexity. So let's see how we're going to do it. Now if it's just one node, that means it does not have a cycle, so no cycle in one node. Then if there are 2 nodes, then this does not have a cycle, but if it points back to 1, then this has a cycle. So how are we going to actually do it in constant space? So there is some algorithm called fast and slow pointer, and that's basically it's a proved algorithm that in any linear structure, if you move your index or pointer basically move one slow, which means just move it one by one, and you move the next one basically by 2 index or 2 pointers, basically going, if you're moving slow from 1 to 2, you will move fast from 1 to 3, and from 3 to 5, and the other one will keep moving from 1 to 2 to 3 to 4. So they say if ever our linked list, let's say this one, it were ever supposed to or were to have basically a cycle, then there will always be a case where our fast and slow pointer will basically be at the same place. And why? And that's I can basically show you here, but that basically comes from the algorithm. It's a proven, it has a mathematical derivation that has been done. It has a formula, but we're not doing that. That's not really, we're not gonna go in that deep. I have seen it, but I'm not just gonna, and that too just long time back in college. However, let's move our let's say our slow pointer is this, and initially our fast pointer is over here. So that's slow and that's fast. We just wanna like prove it. Come on, yeah. So initially they'll be pointing to the head. Then we'll have a loop where we are checking if fast and fast exists and fast dot next exists, because fast will be moving much faster than slow, and it will, if there were no cycle, then it will reach the end of the list first. So that's why we'll have in our while loop checking if fast dot next actually exists, and fast also exists. So let's move fast. So slow, you know what, I'm just gonna have the color rather than having written this. So this is basically our slow, and this is basically our fast. And I don't know, I haven't changed anything yet, but now when slow will come over here, let's just get rid of this. Our fast will go over here. Then again fast will basically be coming here and moving over here. Slow will be over here. Honestly, I'm not really finding very easy to show it, but then slow will come over here, slow will come over here, then fast, which was over here, then it will again go to basically 1 and 2. So this is 4 where they are basically colliding, and they will point to the same node, and that's just happened really quickly in this case. But later it might happen that just it goes on and on and on, and then after a long time it just meets at that location. However, I think there was like if you go into like its mathematical solution, then I think there is some time, basically number of times it has to loop maximum to basically point to the same node. So this is it. Let's code it up. I think it's pretty easy in terms of the code, but yeah, definitely the mathematical solution must be pretty hard to understand. I'm sure if you're in college you should definitely go through it, but if you're working professional, you're not using it anywhere, nobody cares. It's just for the interviews. All right, so let's have our slow. Slow is pointing to head, and you know what, I'm just gonna write them in same line. Slow, fast, pointing to head and head, while fast and fast dot next, if let's just increment our pointer, because initially they're both pointing to head, so the condition will become true. That's not what we want. So let's increment slow to slow dot next, and then fast to fast dot next. And if fast, it's not just the values, it's the, because values can repeat, it's just that particular node we are checking, and node has two properties. One is value, and which is an integer, and next pointer, so that also has to be same. Okay, if they were ever becoming, or they are pointing to the same node, then that means we return true because we found the loop or the cycle. Otherwise we just get out and return false, because we have traversed till the end. This must have reached, or this must have reached, and then we just want to return false because we didn't find anything. And let's let me zoom out, run it on examples. Looks pretty good. All right, let's submit it, and I'm very hopeful it will be submitted. Now let's write down the time complexity. That would be big of n, and space complexity, as our problem has already asked, it's big of 1. All right, let's go back to AlgoYogi, mark this problem solved. See you guys in the next problem. I really just quickly want to go get through these problems. Not gonna spend too much time. All right, bye-bye.